permutations, combinations is what we are going to do today. Now, there are two important things to remember. So there's something called as permutations and something known as combinations. In permutations, you are majorly interested in arrangement kind of problems, which means that the position matters. So suppose if I pick A and B in the team, now where does A stand in the team versus B is going to be important in permutations. Yeah. In combinations, if you select A and B in the team, it doesn't matter whether A comes first or B comes first. Okay. So your position matters, which means this is different from this. But in combinations, it's about selections. Positions do not matter. Which means it's pure selection. Which means whether AB, within AB, A goes first or B goes first, it doesn't matter. So these should be regarded as one count. But these will be regarded as two counts in permutations.
Yeah.
Yeah. All good. Number of permutations is given by a formula called as NPR, where N is the number of data points and R are the arrangements to do.
Yeah.
Yeah. And the two formulae for NPR and NCR are these.
Yeah.
Okay. You're out of N, you're selecting R, and you're out of N, you're arranging R, basically. So that's
Yeah.
how I would read it. So out of N, arranging R items. And this is out of N, selecting R items.
Yeah.
Okay. Examples of how to calculate. Suppose if I give you 6p2, so that should be calculated as 6 factorial divided by 6 minus 2 factorial. Now, what is factorial? Factorial, n factorial is basically the number multiplied by all the subsequent numbers which are below it, all the way till 1. So that's n factorial. So example 5 factorial equals to 5 into 4 into 3 into 2 into 1. Yeah, which is whatever, 120. So 6p2 will be 6 factorial divided by 4 factorial, which is 6 into 5 into 4 factorial divided by 4 factorial. So answer is 30. I can write 5 factorial also as 5 into 4 factorial. I can also write this as 5 into 4 into 3 factorial, or 5 into 4 into 3 into 2 factorial. Basically, whatever is the successive next digits, their product can be replaced by its factorial. Yeah. So that's what we have done here. This is 6p2. Any questions here?
No.
Or okay. Similarly, what is 6c2? 6c2 will be 6 factorial divided by 2 factorial divided by 4 factorial, because the formula is NCR is n factorial divided by R into n minus R factorial. Yeah, so this will be calculated as 6 into 5 into 4 factorial, 2 into 4 factorial. This gets cancelled, answer is 15. Yeah, you can expect 2 to 3 questions at least on permutations and combinations, as well as counting. So all these are clubbed into one.
Mm-hmm. Yeah.
Okay, let's start solving some questions. Okay, and there's a certain pattern in terms of attacking these questions. Okay, so let's start looking at some of these questions and approaches. So here the question is, a quiz has 10 true false questions. If each question can be answered with true or false, always whenever you are faced with a question, first ask how many outcomes are possible per choice. So here there are 10 questions, right? But if any question will have either a true or a false. So can I say 2 choices per question?
Yeah.
Also, all questions are answered and none of them are left blank. In how many ways can the quiz be answered? Yeah, so can I say that, suppose I have these question 1, 2, 3, so on and so forth, all the way till question 10. Now, question 1 can be filled up in how many ways? 2 ways, right? Either the answer could be true or false. So 2 ways.
Yeah.
Same is the case for Q2. True or false. And hence, can I say every question can be attempted in 2 ways? All the way till question number 10.
Yeah.
And hence, the final answer will be just the multiplication of each of the questions' number of choices. So answer becomes 2 to the power 10. 10 times 2 repeats.
Yeah.
Now we don't have to multiply this 10 times on the calculator. We have to remember some powers of 2 for the exam. For instance, 2 cube is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 64. We have to remember at least these powers of 2. So
Yeah.
clearly, since 2 raised to 5 is 32, can I write this as 2 to the power 5 to the power 5, which is 32 into 32? And
Yeah.
clearly the answer should be greater than 900 because 30 square is more than 900. There's only one answer, so answer is E.
Yeah.
So the way you'll get a counting or a permutations combinations problem correct is by setting it up properly. So here
Mhm.
we had to realize that each question has 2 choices. So if there's only one question, okay? Only one question. Can I say the answer will be 2? Either it will be true or it will be false. If there are 2 questions, what will be the combinations? Both can be marked as true. One of them can be marked as false, or both can be marked as false. So there are 4 outcomes, which means 2, 2, 2 cross 2, which is 4. And if we keep generalizing like this, if we have Q1, Q2, Q3, it becomes 2 cube and so on and so forth.
Yeah.
Yeah. So since 10 is a large number, you can't enumerate like this. And hence we need to apply some generic method here, which is basic counting principle. So every place can be filled up in how many ways, and that's going to be important. Next question. Jerome is buying a new computer and has to decide which components to choose in the computer. He's choosing amongst 3 CPUs. So always I write, okay, CPUs 3, RAM 4, hard drives 3. If any of these components can be combined with any of the others, and Jerome must have one and only one of each type, which means, can I say, these are the choices, but how many required? Can I say are one each, correct?
Yeah.
In the final combination. How many different configurations can Jerome select from? So can I say in the first case, the selection will be from how many? Out of 3, you can select one, right? So whenever we talk about selections, okay, we have to use NCR formula. And whether you have to use selections or whether you need to use permutations and arrangements will be given in the question generally, somewhere in the question stem. So here, clearly it's written select, which means it's a matter of choice, which means it's not arrangement. Whether you select CPU first or RAM first doesn't matter. Okay, so it's a matter of choices here, only selections, not the arrangements. So how many ways I can select CPU? Out of 3, I can select in one way. So that is 3C1. Similarly for RAM, out of 4 choices, I need to select 1. So that's 4C1. In HD, I need to select 3 out of 1. So 3C1. And the final outcome will be the multiplication.
Yeah.
One important thing in combinations in NCR, first of all, the formula is n factorial divided by r minus r factorial into n minus r factorial, which we have done. 2 rules. NC1 is equal to n and NC0 is equal to 1.
Yeah.
Okay. Which means if I give you 6C1, that is 6. If I give you 6C0, that is 1. So these will simplify a lot of things, especially the NC1.
Yeah.
So in our problem now here, we have 3C1. So can I say that's equal to 3? 4C1 is equal to 4 and 3C1 again is equal to 3.
Yeah.
So the answer is 12 into 3, 36. Selections problem. Okay.
Yeah.
Because directly it's given here. Most probably there will be a word which will help you understand whether it's arrangement or whether it's selection. If it's not given, then you need to infer from the given context, whether it's arrangement or selection.
Yeah.
Wherever position matters, it's an arrangement and a permutation problem. Okay, next. We've already done factorial concept.
Yeah.
All right, next question. There are 10 finalists for the school spelling bee. A first, second, and third place trophy will be awarded, and there can be no ties. In how many different ways can the judges award the 3 prizes? So always put blanks for the positions which you need to fill up. So there are 3 prizes. So hence there are 3 blanks here. Now the first blank, can I say there could be 10 possibilities because there are 10 finalists. So the first prize can be filled up in 10 ways. The second prize, because first will be selected, can be filled up in 9 ways. And the third prize, since 2 of these will be done by then, first and second, the third can be selected in 8 ways. And the product of all these is 720, which is the answer. Yeah.
Yeah.
Any
Could
questions?
Could you also use permutation for this or not?
You can. You can also write 10p3. So out of 10, you are arranging 3 out of them.
Yeah.
So this becomes 10 factorial divided by 7 factorial, because it's n divided by n minus r factorial, which is equal to 10 into 9 into 8. Same.
Okay.
But I prefer the first method. And the only reason is because in complicated setups, you can't generally use this formula. Counting principles are very handy for complicated or complex setups, or where the logic turns or shifts because of constraints. Then your formulae don't really matter.
Yeah.
So most of the problems should be solved using first principles.
Yeah.
Which means we need to ascertain how many ways in which every space, blank position can be filled up. Also, if I say that A, B, C are first, second, third, can I say this is different from B, A, C, where B is first? And hence here, this is a problem of arrangement, which is why we have used permutations here.
Yeah.
So always cross-verify this with logic.
Yeah.
Clearly, A coming first, B coming second versus B first, A second, both are different outcomes, should be treated differently. And hence, it's arrangement problem.
Yeah.
Yeah. Okay. Next. Gloria has 7 shirts to display on 7 mannequins in her boutique. She has already placed first shirt on mannequin 1. Okay. And how many different shapes can she display the rest of the shirts? So can I say there are 7 mannequins? So 7 positions. But there's a constraint here. She's already placed the shirt here. Already done. Which means position number 2 is left. Placement problem is also arrangement, by the way. If you see the word placed, it's generally arrangement.
Yeah.
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 Okay. So now, can I say first one is ruled out? It's already blocked. From the second position onwards, can I say there will be 6 shirts left?
Yeah.
So hence 6 ways of putting up. And after you exhaust the second place, when you come to the third place, third mannequin, can I say 5 choices will be left? And so on and so forth. And then you can multiply all these. So answer is 720. So this is 30. 30 into 4 is 120. This is 6. 120 into 6 is 720.
Yeah.
Yeah. Got it, right?
Yeah.
So usually there will be constraints and those have to be taken care of. Okay. Now the quant comparison question. A is the number of ways to line up 4 objects chosen from 7 different objects. Is this permutations or is this combination?
Permutations.
Yeah, because you're talking about lining up, arrangement. Yeah, so wherever you have placed, lined, arranged, all that is permutations. Okay, so A can be written as 4 out of 7, right? So 7p4. And what's B? 10p3.
Yeah.
Again, line up.
Yeah.
And hence, all that we have to do is now try to solve this, simplify. This is 7 factorial divided by 3 factorial. This is 10 factorial divided by 7 factorial, which means this is 7 into 6 into 5 into 4. And this is 10 into 8 into 7. Sorry, 10 into 9 into 8. Okay.
Yeah.
So which one is higher? So this clearly 720, easy to calculate. And your, can I say, any combination with 5, you combine something like 20. This is 42. This is 840. So A is greater than B.
Yeah.
So it's very cumbersome to keep typing, right? 7 into 6 into 5 into 4. Here it's best to, if possible, if you can increase your speed by calculations. So combine easier terms to multiply with. So I generally combine 5 with something like a 2 or a 4, which gives me a 10 multiple, which is then easy to multiply with some other number.
Yeah.
Just like this is 72 into 10 is 720.
Yeah.
All right. Another question. If there are 5 books you want to buy at the bookstore, but you can only afford 3, and how many ways can you buy 3 out of 5? So is this permutations or combinations?
Combinations.
Yeah, because suppose you select book A, B, C. Now, whether you select A first or B first or C first doesn't matter. It's about choosing them, right?
Yeah.
So this is clearly combinations problem. And this is easy. Out of 5, you want to buy 3. So 5C3. So this is 5 factorial divided by 3 factorial into 2 factorial. Numerator is 5 into 4 into 3 factorial. Denominator is having 3 factorial, that gets cancelled. Answer is 10.
Yeah.
Any questions?
No.
Okay, let's move on. From a box of 12 candles, you have to remove 5. In how many different sets of 5 candles could you remove? Remove means again selection only, right? Select and remove. So is this combinations or is this permutations?
Combinations.
Yeah. Because if you remove ABC, that's similar to removing BCA. It doesn't
Yeah.
matter in which order you're removing. So it's combinations. So can I
Yeah.
say this will be 12C5
Yeah.
is the answer? And can you calculate and tell me what
Yeah.
should the answer be?
D 792.
Yeah. Okay. Next, how many distinct combinations of 3 socks could be made by randomly selecting socks from a drawer containing 8 differently colored socks? Clearly, it's combinations that's given already. Out of 8, you need to select 3. So answer is 8C3.
Yeah. A,
Is it
56.
56? Okay. Right. Another one. If 8 schools are all in same conference, how many soccer games are played during the season? If the teams all play each other exactly once, which means any team 1 is going to play team number 2 all the way till team number 8 only once. That is what it means. And once T1 is exhausted, T2 can play, say, with T3 onwards because it's already played with T1, so I don't count that. So T2 can play with T3, T4 all the way till T8. And the number of ways in which this can be done, T1 with the other teams, can I say how many ways is that? 7 ways.
Yeah.
And T2 with other teams is how many ways? Obviously 6 ways, one less. And we keep on doing this. T3 can now play with T4 because you can't combine T1 and T2 here. Already that match has happened. So T3 with T4, T5 all the way till T8. Those are 5 and so on and so forth. So answer is 7 into 6 into 5. Okay.
Yeah.
Is it into or is it plus? Now you have to tell me this. We are not talking about positions here. We are talking about the number of matches. So your 7 matches will be played, your 6 will be played. So it's not going to be multiplication. These are number of matches, right? And we are finding out how many combinations here, then how many here, then how many years. So these have to be added. So 7 plus 6 plus 5 plus 4 plus 3 plus 2 is the answer.
Yeah.
This is one way of doing it. The other way is that you need 2 teams to play a match. Two teams to play one match. And hence a shortcut will be to do 8C2. So out of 8 schools or 8 teams, how many ways can you select 2? So this will be 8 into 7 divided by 2, which is 28. Which is also equal to this 28. So method 1 and method 2. Another related problem is, and I'll write it here, related problem is number of handshakes. Suppose there are 10 people in the room and they can only shake hands once with each other. So how many handshakes are exchanged? So that again will be 10C2 because 2 people needed to make one handshake. So how will you select 2 people out of 10? Essentially. So those are the number of ways in which it can be done. Got it?
Yeah.
Yeah, so this is a peculiar variety in which you have to ascertain that or utilize the fact that two teams make a match. So in how many ways can you select two teams out of the total number? Those would be your number of choices, selections.
Yeah.
Okay, so that's that. All right, that's the end of the counting.
Question.
Yeah,
For the previous question, would you say the first method or the second method is faster?
second method.
Second.
But if you were not to understand that it's HC2, then the first method is basic counting method. Always, if you're not able to understand what to do, go back to basic counting, first principles. And the
Yeah.
first method is basic counting.
Yeah.
So I take the first team, it can play a match with 7 other teams. Then when I go to team number 2, it cannot play with 1. It's already played with 1 already. So you can then have only 6 combinations. If then I go to T3, it's already played with 1 and 2. So the remaining matches
Yeah.
will be with T4 all the way till T8. So again, this is a first principles way of solving this problem. Yeah.
Yeah.
Now, combinations are done. Countings are done. We will now go to probability. Okay.
Yeah.
Now, what is this probability? Probability is basically number of desired outcomes divided by total number of outcomes.
Yeah.
Yeah. Which means there's a numerator and denominator. Denominator is total number, and with a certain constraint or with a certain experiment, the desired outcomes are the numerator. Always probability is less than equal to 1 and greater than equal to 0.
Yeah.
Next question. Now, same counting principles are used, just that now we have probability, which means count divided by total count. So whatever we have used, now we are going to use it in a probability format. Okay. Now, the setup is one marble is randomly selected from a bank that contains 4 black, 3 red, 5 yellow, and 4 green. Black, red, yellow, green, 4, 3, 5, 4. I never write the whole word. It's just wastage of time. As you can see, I'm writing just shorthands. Okay.
Yeah.
And if B is repeated, then I write the second letter. Okay. Quantity A is probability of getting or selecting either a black or a red marble. So A is what? Black or a red. Can I say those are 7 choices?
Yeah.
So it will be 7 divided by, and how many total? 7, 12, 16. So A is 7 by 16.
Yeah.
Got it? And what is B? Selecting probability of selecting yellow or green, which is this. That's 9 divided by 16. Only one marble is selected, right?
Yeah.
Now, I've directly written this. Ideally, you should be writing 7C1 divided by 16C1. And here 9C1 divided by 16C1. Answer is the same. But here, since only one was selected, I directly wrote the number because I know NC1 is equal to N.
Yeah.
Yeah.
What's a C1?
Which one?
What is C1?
16C1 combinations is 16. NC1 is equal to N.
Oh, okay.
Out of N, you're choosing one, basically.
Yeah.
So had the question been 2 marbles are randomly selected? Okay. Let's modify the question.
Yeah.
And I say 2 marbles selected. Modification. So then this would have been answered as A would have been 7C2 divided by 16C2 and B would have been 9C2 divided by 16C2.
Yeah.
Again, B would have been greater than A because N is higher than the N in A.
Yeah.
Yeah. Okay. Next, X integer selected at random from this set. And what is quantity A? Probability that the average of 8, 16x is at least 17. Okay. Let's analyze A. They're saying average of 8, 16 and x should be greater than or equal to 17. I'm just writing what they have stated in an equation format.
Yeah.
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 So can I write this as 24 plus x greater than or equal to 51 cross multiplying?
Yeah.
So x greater than or equal to 27. So if that is the case, if you observe this set, it has 3 numbers, 27, 30, and 33. And hence the probability becomes 3 divided by 7. Total 7 numbers, and you select these 3, one of these 3. Basically, it's 3C1 divided by 7C1.
Yeah.
And 3 by 7 is less than half. So answer is B.
Yeah.
So this problem combined averages and probability both. And also algebra, because you had to set up the word problem in the format of an inequality. Yeah, so 3 concepts tested together. And this is typical of GRE. Multiple concepts can be tested together. Yeah, but we have to stick to our basics. Average is greater than or equal to 17. I've just written in an equation format. And hence x greater than or equal to 27. There are 3 choices. You have to be careful whether it's less, greater, greater than equal to. So here it is greater than equal to, which means 27 is also selected as part of the numerator. So 3 choices, 27, 30, and 33. And that's what we have here. 3 by 7 is the answer.
Yeah.
Okay. Next. Aquarium keeps 72 fish in 4 different tanks. So tank 1, 2, 3, 4. Now it's not giving us direct figures here, but we know total is 72. Okay, no worries. Second tank is 4 more fish than the first. So this is x plus 4. Third tank is 4 more fish than the second. This is x plus 8. And fourth tank is 4 more fish than the third. So x plus 12. Each of these have 4 more. Yeah.
Yeah.
So they're asking what is the probability that a given fish will be from the third tank. So this will be simple, right? It will be tank 3 divided by total is what we want.
Yeah.
Or T3C1 divided by total C1 is what they're asking, which is what I've written, correct? Now to find T3, obviously we need X.
Yeah.
Okay. So how do we find X? Can you tell me what is X?
Mhm. X is 12.
X is 12. Okay. So what's the answer?
20 over 72.
Okay. So that's 5 by 18.
Yeah.
Okay. Yes. Okay. Next. A jar contains pink, blue, white gumballs. Pink, blue, white. 15 are pink. Okay. Number of blue is 3 more than twice the number of white. Twice the number of white plus 3 is blue, correct?
Yeah.
Thrice 3 more than twice the number of white. Okay. Probability of pulling a pink or a white gumball out of the jar is 2 by 3. So pink or white divided by total is 2 by 3, which means they're combining these two, which means 15 plus W divided by total, which is 18 plus 3W, should be equal to 2 by 3. So what's W? And they're asking, by the way, blue gumball. So once you have W, we can find B.
Yeah. W is 3 and B is 9.
A is 9.
Yeah.
You mean W is 9
Yeah, W is 9. No,
or blue?
W is 3,
Okay, W is 3 and
blue is 9.
all right. Let's see. Yeah, blue is 9. Nice. There are two important concepts in probability. One is called as independent and the other called as dependent. Now, independent means that when you draw, say, two balls or two blue marbles in a row, you're replacing the first after taking it out of the bag, which means first and second events have no bearing on each other. So hence, independent events are like replacement events. So you draw the first ball out and you put it back. And hence the second has no bearing, which means we're talking about replacement kind of problems.
Yeah.
Yeah. And the second case is dependent, where the second is dependent on the outcome of the first. So this is without replacement.
Yeah.
Okay. So let's solve a problem on this. What is the probability of rolling a number greater than 2 twice in a row on a fair 6-sided die with each of the numbers 1 to 6 on each side? It's simple. There's a die, and obviously there are 6 outcomes there. Numbers 1 all the way till 6, correct?
Yeah.
Twice in a row. Can I say I do this once, then I do it again?
Yeah.
When I do it again, will the first one have any bearing on the second one? Suppose I roll a die and then I take the die back and again roll it.
Yeah.
Second one, does it have any bearing on the first one?
No.
Or first on the second one, rather? No, right? They are independent of each other. And hence, there is no dependency. So this is with replacement, which means numbers can repeat.
Yeah.
You can get a 1 when you throw a die, and again, if you throw it, you can get another 1. And hence it's a replacement problem. Yeah. So number greater than 2. Now, can I say there are 4 numbers greater than 2? 3, 4, 5, 6. So this is 3, 4, 5, 6, correct?
Yeah.
Are the outcomes in the numerator.
Yeah.
In the denominator, obviously, you have 1, 2, 3, 4, 5, 6 total outcomes. And hence, probability in the first one will be what? Any 1 out of 4. So 4 by 6. And in the second, since it's with replacement or the die is again rolled, it will be 4 by 6. Now this I will simplify before multiplying. So this is 2 by 3 square, so 4 by 9.
Yeah.
Yeah. Next.
Yeah.
Okay. Now this is a without replacement problem, clearly given you. Now what is the problem? In a bag, there are 6 red, 7 blue, and 3 black. If 2 marbles are drawn without replacing the first, okay, 2 are drawn.
Yeah.
Okay. Fine. 2 are drawn without replacing the first, okay?
Yeah.
What is the probability of drawing a blue and then a red marble? So can I say on the first go, we are drawing a blue marble, and on the second go, red marble.
Yeah.
Totally, there are 16. Now, can I say in the first go, you need a blue. There are 7 blues out of 16, so the probability becomes 7 by 16.
Yeah.
Correct? And in the second case, a red one is required. But it's without replacing, which means once you remove a ball, you can't put it back, which means now we need another row called as n, number. In the first case, can I say there were 16 balls? And in the second case, already 1 is drawn, so there are 15 outcomes remaining.
Yeah.
So hence, number of red will be 7. It will be 6 divided by 15. And the multiplication of these two will be your answer.
Yeah.
First draw and second draw. Hence, we are multiplying. Wherever there's an and, we multiply.
Yeah.
Especially when we are combining 2 different outcomes. Okay, so 7 by 16 into 6 by 15. This can be simplified, and this is 7 by 40.
Yeah.
So this is a problem without replacement. Okay. So we have covered with replacement, we've covered without replacement. Yeah. We've looked at a lot of other counting examples. I will be sharing some sample exercise problems with you, which you can solve and see if you're getting them. Some of those would be medium to tough difficulty level, which we can then discuss in the next session.
Yeah.
Sounds good?
Mm-hmm.
Okay. Any questions for me?
No.
Okay. Bye. All right. Take care. See you soon.
You know.
Thank
Good
you.
night. Bye.
Good night. Bye.